This video is going to be our midterm review for quadratic functions, and we're going to look at this first question. You need to be really strong both algebraically and being able to use your calculator for this unit. So let's look at this first quadratic function, y is equal to negative 2x squared minus 6x plus 20. So the first thing that we want to do is we want to look at this function, and we can only sort of determine two things when it's in its expanded form. So our a value is negative 2. And remember, when we have an a value less than 0, that tells us that the quadratic function is going to open down. So if a is less than 0, the quadratic will open down. This is the c value, which is 20, and that gives me the y-intercept of the graph. So I have a y-intercept of 20. So this graph will cut through 20 on our y-axis. It's going to open down and it's going to cut through 20. So what I want to do is first, let's make sure we can punch everything into our calculator. So in y1, let's enter this quadratic equation. So enter in negative 2x squared minus 6x plus 20. When we graph that, here's our quadratic opening down. It looks like we could see our two x-intercepts at 2 and minus 1, 2, 3, 4, and negative 5. But we want to change our window so that we could see the vertex. So let's change the window, and let's go to a y max of 30. I'll change the scale to 5, go up by 5s. Okay, so let's sketch this. So it looks like this was at 2, which we're going to confirm on our calculator, and this x-intercept at negative 5. We'll complete the square, or no, we'll factor in order to get those x-intercepts. But let's do a couple of things. Okay, so x and y-intercepts. Y-intercept, again, is your c value. X-intercepts we're going to get on our calculator by the zeros. So remember this x-intercept here, second trace, and I want a 0. So I want to go left of the x-intercept, so I'm going to hit my left arrow, hit enter, and then I want to go right of the x-intercept, which is below the x-axis, guess, enter. So I've got an x-intercept at 2. I want to check this x-intercept. Second, calculate a 0. If I want this x-intercept over here, I first go left bound, so my left arrow, and then I'm going to go right bound, right arrow. So negative 5 and 2. Okay, so if they want it as ordered pairs, my x-intercepts are negative 5 and 2. My y-intercept, x is 0, y is 20. Remember, on your calculator, in order to be able to get your y-intercept, you're just going to go second trace again, a value, when x is 0. And when x is 0, y is 20. Okay, so one of the ways that we could have gotten our intercepts, our x-intercepts, was by graphing it. But we could also get our x-intercept by factoring. So let's look at this equation here, and let's say how would we factor this. So y is equal to, I'm going to take out a GCF of negative 2. So if I GCF out a negative 2, I would get x squared plus 3x plus 10. And then this would be a factoring by inspection question. And I would get y is equal to negative 2. Two numbers that multiply to 10 and sum to negative 3. Sorry, when I divide out a negative 2, that becomes positive. This becomes positive, and this becomes negative when I'm dividing out a negative 2. Okay. So 5 and 2, and it would be positive 5 and negative 2. So x plus 5 and and x minus 2. And remember, once you factor, you set your, if we're finding x-intercepts, let y equal 0. And then our x-intercepts are x is equal to -5 and 2. Okay? Coordinates of the vertex. We are going to get the vertex by completing the square. I'll do completing the square in a different question. So right now I just want for this question to make sure you could use your calculator. So the vertex would be right up here, and that's a maximum on this graph. So to get the vertex, second trace, and it is a maximum number 4. So we're going to go left of the vertex, right of the vertex, and enter. So there's a vertex at -1.5 and 24.5. So -1.5 and 24.5. Okay, so that's the coordinates of the vertex. The axis of symmetry comes from the vertex. So the axis of symmetry, quadratics or parabolas are symmetric. And this would be my invisible axis of symmetry. And the equation of that line always comes from the x value of the vertex. So the equation of that line would be x is equal to -1.5. That's the equation of the axis of symmetry. Remember, another way that I could get that value is it's going to be halfway between -5 and 2. So half of -5 and 2, what I would say is I would say, okay, x is equal to, it's the average, so -5 plus 2, and divide that in half. X is equal to, -5 plus 2 is -3 over 2. X is equal to -1.5. The equation of the axis of symmetry, again, it would be x is equal to -1.5. Okay, domain and range. We'll do both interval notation and set builder notation. So the domain of this graph in set builder notation, this would go to positive infinity and to negative infinity. So x is such that x belongs to the element of real numbers. In set builder, the domain, our x's, go from negative infinity, sorry, in interval notation to positive infinity. The range of this graph, the biggest y value on this graph is from the maximum at 24.5. So in set builder notation, y is such that y is less than or equal to 24.5, comma, y belongs to the element of real numbers. That would be the range. In interval notation, doing the range, the smallest y value, this goes to negative infinity. So round bracket, negative infinity, comma, 24.5, square bracket. That would be my range. Okay, quadratics could be in vertex form, or they could be in general form. I always call it expanded form. So this quadratic right now is in vertex form. The reason why this is in vertex form, remember that the vertex from a quadratic is going to be p comma q. Right now this is in the form of y is equal to a x minus p close bracket squared plus q. So in vertex form, the a value is equal to 2, which tells me that the graph opens up. The vertex form, the p value is equal to 1. And remember, that's going to move your graph 1 unit to the right. So that's going to be a horizontal translation, 1 unit right. The q value is -5. And that is going to move your graph up or down, the q value. This is going to move your graph down, so it's a vertical translation, 5 units down. So the vertex of this graph is at 1, comma, -5. So let's put that vertex on. X is 1, and y is -5. That's the vertex of this graph. The vertex is going to be the minimum. This graph is going to open up. Now, in order to get the y-intercept, I want to go into expanded form. So to get this guy into expanded form, it's going to be 2. This binomial, I'm going to write twice, -5. Y is equal to 2. Let's expand this binomial, and we're going to get x squared. We'll get -1 to -1x, which will give me -2x, and we'll get +1. Now distribute in that 2, and we will get 2x squared minus 4x plus 2. Bring down that -5. And then to figure out my constant, it's going to be 2 minus 5, which is -3. So 2x squared minus 4x minus 3. This is the expanded or the general form. Again, my a value is the exact same. My y-intercept, though, is going to be -3. So that gives me my y-intercept. We could check on our calculators if we expanded correctly, and how you would do that is you would plug this into y1 on our calculator, and we'd plug this into y2, and we'd want it to be the exact same graph. So just to check if we did our expansion correctly, the vertex form was 2 open bracket x minus 1 squared minus 5, and our expanded form would be 2x squared minus 4x minus 3. Okay, so I could tell I did this correctly. I'm just going to do Zoom 6 standard. Okay, so this graph needs to be symmetric, but it also needs to go through -3. So it would look something like this. The vertex here is at 1, -5. And remember, what does the vertex give us? The vertex gives us 2 important pieces of information. It gives us my axis of symmetry at x is equal to 1. So that gives you the equation of the axis of symmetry. And the y value gives us the minimum value. So x is equal to -5 is the minimum value. So the range of this function would be the smallest y value is -5 and it goes to infinity. Or the range in set builder would be y is such that y is greater than or equal to -5, comma yer. Okay, but that is going from expanded to general form. All right, let's solve using the square root principle. So what we want to do is we want to isolate this x minus 1 squared, so let's add 16 to both sides. So I'd get x minus 1 squared is equal to 36. We want to get x by itself, but right now this binomial is being squared. So to get rid of a square, we're going to do the opposite, which is square rooting. We'll be left with the radicand, which is just x minus 1. And remember, the square root principle says that when you square root both sides of an equal sign, we don't just get 36 as an answer, we get plus or minus. Sorry, we don't get 6, we get plus or minus 6. So I've got 2 different answers. I'm going to have x minus 1 is equal to 6, and x minus 1 is equal to -6. So one of my answers is x is equal to 7. And one of my answers, if I add 1 to both sides over here, I get -5. Minus 1. Sorry, x is equal to -5. Okay. Okay, let's review solving by completing the square. So I'm going to give you 2 that we are going to do. let's do negative 2x squared plus 4x plus 3 is equal to 0. And 3x squared plus 18x minus 2 is equal to 0. So remember, when we complete the square, we put brackets around our first two terms. And what you want with your first two terms is you want to have a 1 in front of your x squared. So we want to get rid of that negative 2 by factoring it out. So let's factor out that negative 2. And we would get, in the bracket, x squared minus 2x. Remember, you want to leave yourself some space. And then we've got that plus 3. Okay, once you have a 1 in front of your x squared, we're going to make our magic number by taking that negative 2, and you're going to divide that by 2. And we will get negative 1. Whatever number you get there, you're going to square it, and we will get a plus 1 here, and then we're going to get minus. If you add 1 in here, we got to balance it by subtracting 1. Now remember, because we factored out that negative 2, I have to multiply this by negative 2. So what I would have is, I'm going to bring down that negative 2 on my x here. F here, 3 will give me 5. So plus 5 is equal to 0. Right now, I'm essentially in vertex form, right? My a value is the same. It's negative 2, negative 2. This quadratic is going to open down. I now know the vertex of this graph, though. The vertex of this graph is going to be at 1, comma 5. So I've got the vertex of this graph. But what I could do, if I want, is I could continue this, and I could what's called solve by completing the square. So I want to isolate basically I want to get my x-intercepts by solving. So from here, I'm going to isolate my x minus 1 squared. So let's add 5 to both sides and divide by 2. Divide by negative 2. So x minus 1 squared is equal to negative 5. And then divide this side by negative 2 and this side by negative 2, and I get x minus 1 squared is equal to 5 over 2. I want to get my x-intercepts, essentially is what I'm doing right now. So I want to get rid of this square by square rooting. So square root this side, square root this side. Over here, I'm going to have x minus 1 is equal to, this is going to be plus or minus root 5 over root 2. Okay. From here, to get my x-intercepts, I'm going to add 1 to both sides. Actually, you know what? Maybe I'll do. Maybe I will rationalize first. I'm going to get rid of this root 2 by multiplying this by root 2 and this by root 2. Plus or minus root 10 over 2. Okay, let's add 1 to both sides. And this is what my x-intercepts are going to be. Now, from rationals, we now know that we can combine these two fractions. Multiply that by 2 and this by 2. X is equal to plus or minus root 10 plus 2 over 2. These are what my two x-intercepts are going to be. So I'll show you sort of on a calculator how we can confirm this. So punch this into y1, negative 2 x squared plus 4x plus 3. We know that we can get our x-intercepts just by finding the zeros. So second, calculate a 0. We'll go left of the 0 and right of the 0. So one of my x-intercepts is this 2.58, but that's an irrational number. It's going to say on your test, what is that as an exact value, right? So as an exact value, it's going to be one of these two answers down here. But I'm just going to put that on my calculator. So there's that 2.58. The other x-intercept, 0. It's this guy over here. So go left of the 0, go right of the 0, and enter. That's my second x-intercept. Those numbers as exact values would be these numbers here. So to confirm with you, I'll get my fraction. So alpha y, number 1. So I'm going to type in negative, or I'm going to type in root 10 plus 2 divided by 2. Okay, so that was this x-intercept. And then the other x-intercept would be the negative. And that would be that guy. So we'll do one more of these, just if you had a harder time following this one, I'll do a second one with you. So let's do this guy. We could get the x-intercepts by punching this into our calculator. But in order to get it by completing the square, brackets around the first two terms. Then you want a 1 in front of your x squared. So I'm going to factor out the 3. That will give me x squared plus 6x. Leave yourself some space. The minus 2 can go there. What we're doing is we're going into vertex form by completing the square. You take that middle number and you divide it by 2. And we're going to get plus 3. When you square that, you'll get plus 9. If you add 9, balance by subtracting 9. Then say to yourself, don't forget to multiply it by whatever you factored out, which was the 3. If we typed in, this would be negative 2 minus 9 times 3, so negative 2 minus 27. That would give you negative 29. Put an x here and bring down that 3. We've just converted from expanded form into vertex form. The a value is the same. A is 3, A is 3. Now I know what my vertex is, though. My vertex is at negative 3, comma, negative 29. To get the x-intercepts, though, I could solve it by completing the square. So I want to isolate this. So bring the 29 to the right-hand side. And I had a 3 in front. And then remember, we want to divide both sides by 3. And what we would get is we'd get x plus 3 squared is equal to 29 over 3. From here, let's square root both sides. And we're going to get x plus 3 is equal to the square root of 29 over the square root of 3. I'm going to rationalize this by multiplying this by root 3 and this by root 3. And I'll get x plus 3, sorry, this should be plus or minus, plus or minus, plus or minus. 29 times 3 is 87 over 3. Then I want to get x by itself. This is going to give me my x-intercepts. So I'm going to have x-intercepts at plus or minus root 87 over 3 minus 3. To get common denominators, multiply this by 3 and this by 3. My x-intercepts are plus or minus root 87 minus 9 over 3. Again, how I confirm that this is correct is I can punch in my original equation in y1, and I could get the zeros using the graphing function. And then those zeros would be these two x-intercepts here.